Last time we looked at derived quantities and unit. And if you've been following, by now you should be able to differentiate between fundamental quantities and derived quantities. The same thing, you should be able to distinguish between fundamental unit and derived unit. Okay? So today you want to look at dimension of physical quantities. Dimension in physics usually denote the physical nature of a quantity. It usually denotes what? The physical nature of a quantity. So any quantity which can be measured in a unit of length have a dimension of length. That is, distance is measured in unit of length. So distance has a dimension of length. Height is measured in unit of length. So height has a dimension of length. The same thing, displacement. All right, so any quantity that has a unit of length has what? A dimension of length. Okay. Also, any quantity which can be measured in unit of time has a dimension of time. In unit of time simply means days, right, are in unit of time. Hours, weeks, years are in unit of time. So they have a dimension of time. Any quantity which can be measured in unit of mass, either kilogram, gram, okay, they have a dimension of mass. All right. The dimension length is being specified by capital letter L. The dimension time is being specified with capital letter T. The dimension mass is being specified with capital letter M. All right, so we are going to pick some of these derived quantities and analyze them using this dimension, and that principle is known as dimensional analysis, okay, or the dimension of physical quantities. Okay, now the next one is force F, and force is what? Mass times acceleration, right? Our dimension of mass is m times the dimension of acceleration. We have done it, which is L per minus 2, right? This is the dimension. So what I'm going to have here is just multiply mass length per time square. Okay, this is the dimension of our force. Work. We know that work is force times distance, right? And the dimension for our force is this. So we have m L T times what? Distance, okay? And the dimension for distance, we said what? Is L. Any quantity that has a unit of length, the dimension is what? Length, okay? So you notice that I have L here, I have L here, and they have invisible one, which according to law of indices. So my dimension for work done, I'm going to have m L 1 plus 1. I will add this one, all right, then T minus 2. So what I'm going to have is m L square T minus 2. So this is a dimension of work done. Okay, and also know that work done and energy, they have the same dimension. So this is either work done or energy. All right, either work done or energy, they have the same dimension, which is mass length square per time square. That is the dimension of energy. Okay, next one is power. All right, and power P is equal to work done over time. Okay, we have done for work done. What's the dimension for work done? The one that we just finished now. We have mass L square per t square, L square per t square, then divide by our time. We analyze this, okay, using law of indices. So what I'm going to have is ml square per t square times t minus 1. Okay, so I'll do this. They have the same base, and I'm going to add this and this, that is minus 2 plus minus 1. So what I'm going to have is ml square t minus 2 plus minus 1. Okay, so minus 2 plus minus 1, that will give me minus 3. So what I'm going to have is ml square t minus 3. This is a dimension for power, and it is called mass length square per time cube. That is a dimension for power. So I will encourage you to just go through and look at physical quantities. Try to analyze them dimensionally like this. If you have any problem, any issue analyzing any quantity, just send it to me or drop it. You can DM me, send it as a direct message, or drop it at the comment section, and I will see how I will help you handle it. Don't forget to subscribe, like, okay, share the video with your family and friends. Thank you. See you later.